Hey guys, welcome back to another tutorial. This time we have this question of GATE exam 2001 electronics branch. In this question we have to find maximum power dissipation through Zener diode and transistor. And given that input voltage is varying from 20 volt to 30 volt and output is regulated 10 volt and some relevant parameters of Zener diode and transistor are mentioned. Now let's solve the question. This is the circuit diagram which is given to us. And let's write down what values do we have for the calculation of maximum power dissipation in the Zener diode and the transistor. To turn on the transistor, the required value of base to emitter voltage VBE is 0.5 volts and the value of common emitter current gain beta is 99 and the value of Zener voltage is 9.5 volts. It is mentioned in the question that the current through RB is neglected, means current flowing through RB is 0. If we apply KCL at the base terminal, we can clearly see that the current flowing through Zener diode is equals to the base current. Now consider this node as reference. We can write this node as V0, which is equals to 10 volt. This node is a 10 volt and we are going down by 9.5 volt through the Zener diode path and we will reach at base terminal. Now the base terminal will be at 0.5 volt as this voltage is VZ, which is equals to 9.5 volt. VB is equals to 0.5 volts. Emitter is at 0 volt, therefore V is equals to 0 volt and collector is equal to V0, which is equals to 10 volt. Now VBE is equals to 0.5 minus 0, which is equals to 0.5 volts. It means transistor is on and VC is greater than VB. It means the collector base junction is reverse biased and transistor is operating in forward active region. And in this region we can use the relation IC is equals to beta IB. Now we have to find the maximum power dissipation which Zener diode and transistor dissipates. PZ is equals to VZ into IZ, where IZ is equals to IB and PT is equals to VCE into IC. VCE is equals to VC minus VE, where VE is at ground and VC is equals to V0. Therefore V0 times and IC is equals to beta IB. We can use this relation now. Now we can clearly see that PZ and PT both depends on IB. Now let's find the value of IB. On applying KCL at the output node, we can tell that the current through 20 ohm resistor is equals to the sum of current IZ and IC. Now 20 ohm can be written as V in minus V0 upon 20. Where IC is equals to beta IB and IZ is equals to IB. Now IB can be written as 1 upon 1 plus beta V in minus V0 0.20. Now we want to maximize the power dissipation through transistor and Zener diode, and for that we have to maximize the current IB. Now to maximize IB, we have to maximize the Vin, which is equals to 30 volt, and V0 is at 10 volt. Now we will get, by putting all the values, milliamps. IB is 10 milliamps. Now we can use this value of IB to find the value of PZ and PT. Now PZ is equals to VZ is 9.5 volt and IB is 10 milliamps. We will get 95 milliwatt of power through the Zener diode, and PT will be, VC is 10 volt, beta is 99 and IB is 10 milliamps, and we will get 9.9 volt. We got C as correct option. Thank you guys for watching this video. If you find this video helpful, please like and share it with your friends, and if you haven't subscribed yet, please subscribe for more videos.